In homework 2.6, we're multiplying polynomials. I'm going to start with a fractions one. This is a single thing, multiplying times a binomial. The plus here separates the two terms in the binomial, and multiplying distributes across an addition or a subtraction. And so we've got 5, 6 times 2a. The tricky thing here is multiplying 5, 6 times 2. 5, 6 times 2 is the same thing when you're trying to multiply a fraction times a whole number. You can multiply it by that whole number divided by 1. So it's 5, 6 times 2a over 1. That's still 2a. And so that will be 10a over 6, which is 5/3 a. When you have a number in the numerator, you can put it in front of the fraction if you would like. Another way to think about this one, there's a shortcut way to do this that might have helped, which is you can factor 6 into 3 times 2. And what you'll notice is you've got 5 divided by 3 times 2 times 2a. And what will happen is the multiplying by 2 and the dividing by 2 will cancel out. You can cancel out a multiplication and a division factor. So we get 5/3 a. And then when we get 5, 6 times 4/7, again, we have two methods on how to do that. I'll do this one in red. 5, 6 times 4/7. We can multiply straight across because that's how we multiply fractions. 5 times 4 is 20. 6 times 7 is 42. And then we can simplify that fraction by dividing both by 2 and get 10/21. So the answer is going to be 5/3 a plus 10/21. If you want to see a quick fraction trick, instead of multiplying across and then simplifying, you can simplify before multiplying by dividing. If you have a number in the numerator and the denominator, it doesn't matter which term they're multiplying from, I can simplify here by dividing both by 2. This becomes 2. This becomes 3 when I divide 4 divided by 2 and divide 6 divided by 2. And so 5 times 2 is 10, 3 times 7 is 21, and it skips a step. So there we are. Let's move right along to the next one, or one of these next ones. Let's do number 9. Number 9, this time we have a binomial times a binomial. There's two things separated by a subtraction times two things separated by a subtraction. And here, the first term will multiply times both of the other terms in the other binomial. And then the second term will also distribute to both terms in the binomial. 6k times 6k is 36k squared. 6k times negative 1 is negative 6k. Now the 4 is going to distribute. 4 times negative 6k is negative 24k. And negative 4 times negative 1 is positive 4. You will often notice that the middle terms end up combining because they're like terms. K squared doesn't combine with anything. There are no other k squareds, so we just bring it down. Negative 6k minus 24k, those are like terms, and we can combine them. Negative 6 minus 24 is negative 30, and we bring down the 4. That's the product. One more, multiplying binomials one. This one looks a little bit different, and I'd like to show you what is wrong first. And I'm going to show it to you in a numbers example. Let's say you have 1 plus 3 squared. Well, this is 4, parentheses happen first. 1 plus 3 is 4. 4 squared is 16. What this is not equal to, some people try to distribute squaring across addition, and exponents do not distribute when to a binomial. In fact, we can see that really easily by saying, well, what is 1 squared? That would be 1. 1 times 1 is 1. 3 squared would be 9. And 1 plus 9 is 10, which is not 16. So this is not a legal move. Similarly, I see some students try to square this and then square this, and that is not legal. What we can do is we can take this binomial that's being squared and rewrite it using what we know squaring something means. Squaring means times itself. So this is 5b minus 5 times another 5b minus 5. And now it's just like every other problem where it's a binomial times a binomial. The first term will distribute, and then the second term will distribute. 5b times 5b is 25b squared. 5b times negative 5 is negative 25b. Negative 5 times 5b is negative 25b. And negative 5 times negative 5 is positive 25. these, again, these middle terms can combine, but nothing else can. So we're going to get negative 50b. When you combine like terms, you do not change what type of thing it is. Sometimes I see students write 50b squared or something like that, and that's very bad. Don't do that. On the back, we have more binomials, this time with fractions, and you're just practicing your fraction skills. This will distribute. This will distribute. You can use some simplification tricks. I'm not going to go through that with you. What I would like to go over is one of these last ones. Number 25 is a trinomial. There are three things times a trinomial, and it works very similarly. The first term will distribute to all three of the others. Then the second term will distribute to all three of the others. And finally, this third term, I'm going to wait to show the distributing, but it will also distribute. N squared times 5n squared is 5n to the fourth. N squared times 5n is 5n cubed. N squared times 2 is 2n squared. Next, the negative n will distribute, and be careful that the negative n is multiplying. Negative n times 5n squared is minus 5n cubed. N times n squared is n cubed. Negative n times 5n is minus 5n squared. Negative n times 2 is negative 2n. Last, we've got the negative 3, and that will also distribute times each one of the other three terms. Negative 3 times 5n is negative 15n squared. Negative 3 times 5n is negative 15n. And negative 3 times 2 is negative 6. Finally, we need to combine our like terms. There are no other n to the fourths, so we can just bring that down. 5n to the fourth. There are 2n to the third terms, and so we can add these together. 5n to the thirds minus 5n to the thirds is 0n to the thirds. 0 times anything is 0, and we're not going to write that down. There just won't be any n to the thirds. So they kind of cancel out. You can think of it that way. The n squareds, well, we've got 2n squareds minus 5n squareds minus 15n squareds, and we can combine all three of those. 2 minus 5 is negative 3. Negative 3 minus 15 is negative 18n squareds. We've got some n's. We've got an n here and an n here. They have no exponents. They are like terms. Negative 2n minus 15n is negative 17n. And there is no constant besides negative 6, and so we can just bring that down. That's our final answer. I hope that helped.